All right. Hi, everybody. We're going to take a look at our second lecture here on, which is on high energy society and looking at how you and like just the world in general is using energy. So, looking at the first thing, we're going to start out by just reminding ourselves what power is. So, power is the rate at which we use energy. That would be in joules per second. Um, with the joule being the amount of energy, so obviously joules per second would be a rate, right? The amount of energy, the rate at which you use energy. And then just recall that 1 watt is equal to 1 joule per second. So, um, so yeah. So the question, right, is let's see here. So then, just to give you an idea of like, is a watt a lot of energy? Um, we're going to do 1 minute of knee bends, right? So basically, a knee bend is just like a squat. So here we go. We're going to record a whole minute. Oh my goodness, this will be a lot. So you got to do it too. You obviously can't see me, but here we go. We're going to set a timer for 1 minute. Um, that was not 1 minute. Here we go. So 1 minute of knee bends, just up and down and up and down. Oh, I don't know if we're gonna do a whole. You don't have to go all the way down. Not like the dude that's in the picture there. But the idea here is to give you an idea of like, right, we're using energy as we do knee bends. So, all right, we're 20 seconds in. We got 40 seconds left. Um, and so we're just gonna do this. Keep doing knee bends. Keep doing them. Right? Is your little brother looking at you weird? Um, because you're doing knee bends. You just explain. So this is 100 watts. So you're using 100 joules per second as you do your knee bends. So that's the rate at which your body is turning its stored energy into movement energy basically. So you're losing doing 100 watts doing your knee bends. Keep doing them 3 seconds, 2 seconds, 1 second. All right, we can stop doing knee bends now. So there you go. Hopefully you actually did that. Otherwise, I suppose you just sat there and felt guilty for a minute. So anyway, that can be your exercise while you're sitting in your. You can think about that as your 100 watts. You're doing 100 watts of work while you're doing that. Okay, moving along. So knee bends burn energy at 100 watts. I already told you that. Could have told that earlier. Okay. Um, so the question is, all right, now we know we have a little bit of a feel for like what 1 watt is like, or better yet, we have a feel for what 100 watts is like. And so is that a lot of energy when we think about like us going through our daily lives? Is 100 watts of energy consumption a lot? So let's just take a look at this graph right here. It's over, it's got our per capita energy consumption in kilowatts. So it's kilowatts would be 1,000 watts. And so as we take a look right here, we are obviously in 2020. So we're going to be up here and it's been pretty, since about the 1950s. Um, Pretty constant at about 12 kilowatts. So that means that like if you go through, throughout your day, you're using roughly 12 kilowatts all the time. Now this would include every single aspect of your life. So this would include, your heating your house and feeding you, and driving and transporting from one place to another. And so this would be like everything. Um, all the energy you use. So that's why it's high, meaning that you're slightly less than, you're in the 100 to 120 energy servants per person. So that would be like the number of people doing knee bends. Like if we were to somehow power your life by people doing knee bends, how many people would it take doing knee bends all the time in order to power your entire lifestyle? Okay, so a lot of people. That's 120 people just doing knee bends day in and day out, you know 24/7 to power the our lifestyle. So just to kind of put that in perspective. Okay, so where does the energy come from? So obviously the energy does not come from people doing knee bends. So if we right for the most part, power plants, we're talking largely electrical power, but I mean, of course, you're talking about gasoline um, to move, grow the food that you grow or that you eat. Um, and if we just think about power plants, like where do they get most of their power? Now, here in Washington, we get a lot of our power um, from hydroelectricity, but as the country as a whole, right, it's largely natural gas, oil, and coal still. And so, right, if we think about the amount that is right is from fossil fuels, right, the reason we would be concerned about the amount of energy that we use is that because largely the amount of fuel or the energy that we use is from things that are polluting the environment, right? So we need to think about the amount of energy we use because, of course, impacting the environment. So, um, so let's think about how do you use energy, right? Like so, basically the kind of the energy you use falls into three different categories, right? First up, where you live takes energy. And the kind of house that you have is going to influence how much energy, how energy efficient you are. So, right, it takes heating is probably one of the biggest things. To heat your house and keep it warm takes a lot of energy. So many houses use like natural gas, some use electricity, and so that's going to take energy. The kind of house that you have, right? If you live in an apartment, that's obviously going to be it's actually a little bit more efficient because you have right apartments next to you, so you're not losing energy to the outside walls. Um, you're also more densely packed in there, and so as a result, that's going to be a bit more efficient versus if you have a single family home, and then right how efficiently your home is insulated, and then how big your home is too. We talked about that in the last lecture. So it's also how to power all the things in your home, right? You got your stove and your microwave and your refrigerator and your computer and your TV and like all these things that are going on in your house, right? We have to be, of course, powering those, your lights, so on and so forth. And then the other part of it is water, right? Like as you're every time you turn on the faucet or take a shower or something like that, water is coming right from some some lake somewhere, and it's got to be treated before it gets to your house, and then it's got to be treated after it leaves your house as well, to so that it can right be safe to put into the rivers and stuff like that. And so that's those are all energy intensive things. Transportation, right? Anytime you travel, so when you drive to school or when you ride to school or when those things, you're getting inevitably in a car that's probably burning gasoline and of course using energy there. Um, so anytime you buy something, it needs to be transported. So I mean, we're in this day and age where we're buying things from Amazon and people are delivering it to your door, that's of course kind of an inefficient way of doing things because you know, um, having someone drive something to your house and the other what things if you buy something that's made far away, something that's made in China or something like that, that's got to be flown or put on a boat and brought over here. That's of course using a lot of energy. If you're buying like let's say even like if you think about it like bananas, and this is more in the food one, but like bananas are probably not grown in Washington, so meaning they're flown from someplace else. That's going to be not very efficient in terms of energy. So anytime you fly somewhere, and this is right, obviously this is similar to travel, but like flying is very inefficient when it comes to and bad for the environment, like in a way that driving your car is not. Um, and so as a result, like flying increases your carbon footprint a lot. Carbon footprint meaning like um, wow, it's like like how much how many trees do you need to basically mitigate your carbon output, is your carbon footprint. Um, Food, right? Obviously, anytime when you eat something that is usually grown, and when you grow something, you have to have tractors that are planting it. Um, you have to, have pumps that are pumping water to water it. It needs to be fertilized. It needs to be right harvested, which is used as a tractor again. It needs to be transported, usually in a truck or a plane or a boat, and then a lot of times it needs to be processed. So again, turned into, your cereal. So we're taking grain or whatever, processing it, turning it into, right? All of these things use energy. And then not only that, but like a lot of food is wasted, right? We throw out a tremendous amount of food, especially here in the United States, that um, we've done all these things to get it to the grocery store, and then we just throw it away because it's not used in time or something like that. So all of that energy that was you know used to make it is basically wasted. So these are all the basic three ways that you use energy in your life. Um, so so let's just take this. So let's say instead of people doing leg bends, because that's hard to imagine turning leg bends into electricity. Let's just imagine that you have like a little crank that you can turn, and that crank turns creates electricity. And let's say you're able to make 100 watts. Actually, I don't know if that's reasonable or not. But let's say that we paid them $12 an hour to turn a crank to, um, to power your life, basically. Um, so how much would it cost for 1 kilowatt hour of electricity? So let's see here, 100 watts. So to turn that into a kilowatt, that would right. I need to have 10 people, um, right, making 100 watts because right, 10 is by 100 watts, give me 1 kilowatt. So I would need to get a kilowatt hour, which a reminder is an amount of energy. Um, right, I need to take kilowatts and multiply by an hour. So I would need 10 people. Um, right? At a cranking at 100 watts to give me 1 kilowatt, and then I would need them to do that for 1 hour. And so that means I need to pay 10 people, 10 people for 1 hour. So that's going to cost me, or I would need to pay 10 people $12 an hour, right? $12 an hour for 1 hour, which is going to be $120. So for me to get 1 kilowatt hour by paying people to crank a crank, it's going to cost me $120. So I pulled up my electricity bill from last probably February or something like that. And my house, we use 400 kilowatt hours. My that month's bill was approximately $45. So not that bad, right? So if we think about how much it would cost for my electricity if I had to pay, these people to crank it, that's going to be 400 kilowatt hours times by right $120 per kilowatt hour. Right, my electricity bill would have been, let's see here, 400 times by 120, uh, $48,000. So good thing we don't get our electricity that way, right? Now, obviously, so the purpose of giving you this problem is just to put it in perspective of like how much energy does your life take, right? Like that's the reason we did this problem. Um, is to put it in perspective about how much energy you're using. And like this is just 1 month um of electricity. It's just my wife and I. We have a smallish, well insulated house. And we use, I mean, this is just the electricity bill. Like our house is heated, our water um and our heat are both natural gas. So this is just the electricity. This isn't even, the heating basically. And um so this is, just lights and fans and range and refrigerator and that microwave and that kind of stuff. So um okay, so I painted this picture about like, oh, we're using all this energy and it's terrible, and that's not the point. Right, I mean, part of all of that is just give you an idea about like how much energy we're using. But to just kind of back off on that for a second and say like energy consumption by itself is not necessarily bad, right? Like we need energy to survive, right? You have to eat. So we have to grow food, so that's going to take energy, right? Um, Energy consumption generally improves our standard of living, right? So like, think about the ways that we were using energy, right? Your house, your transportation, um, and your food, right? So your transportation, right? You higher standard of living if you can, fly places or drive places or something like that, right? If you have a bigger house or just things like that, those are energy consumption, generally speaking, the higher your energy consumption, kind of the higher your standard of living. Um, and so, of course, we need to find a balance in that, but like, this is not necessarily a bad thing. And we'll come back to this, but I'm not necessarily advocating on like, saying, hey, we got to stop using energy entirely, but we just need to kind of be aware of everything. And so, I just want to take a look at the other side of this, which just says that like, hey, we should be and we will need to use energy. Um, that's a thing. So I talked about the standard of living. So one of the ways that we kind of think about a standard of living is by thinking of like maybe like a country as a whole, is thinking about the gross domestic product, which is a measure of the total economic activity, right? If things are going well in the economy, that often means that um, right, people are making money, therefore they can afford to travel, they can afford to have better food, they can afford to have a nicer house, right? So generally speaking, your standard of living is going to increase. So because if you think about it, like standard of living is a fairly difficult thing to measure. So this is one attempt at measuring um, standard of living. So is the gross domestic product. So it's going to include personal consumption, government expenditures, private and public investment, product and stories, and net exports. So it's going to look at the economy as a whole. Like that's really what it's trying to measure, but often it's sometimes it's thought of as a way of measuring standard of living. So energy intensity would be the ratio between energy consumption in GDP, gross domestic product, right? So you can think of it as the amount of energy we use versus the amount of stuff that we make or get accomplished, right? So GDP would be kind of the stuff we make or get accomplished, and energy consumption would be how much energy we as a society use. It's going to be measured in watts per US dollar, so the number of watts needed to produce $1 of GDP. Um, so um, so it's our productivity versus the amount of energy we use. So we got a couple different graphs to look at. So here, if we take a look at this first graph here on the left, right, we have our per capita GDP. So in thousands of dollars per year versus the amount of energy we use. So let's see here. We got they got this line here of all that would basically represent the energy efficiency. Technically, slope would equal 1 over the energy efficiency, but don't worry about that too much. Um, so we have countries like the Congo, Egypt, and Poland, which kind of lower on this lines, and then we have countries like Australia and the United States, which are higher on the line, and they would all have the same energy efficiency. Right? If we take a look at this, the energy uses a lot of, or the U.S. uses a lot of energy per person, um, but they also make a lot of things, versus, like let's say Congo or Egypt, they don't use a lot of energy per person, but they also don't make a lot of things. So again, kind of going back to this standard of living thing, you might say, hey, like take a look at this. We use a lot of energy, but hey, we make a lot of things. We have pretty high standard of living here in the United States versus maybe the Congo, where they don't use a lot of energy. They also don't make a lot of things. They don't really, right? If GDP is really an indication um, of standard of living, they maybe don't have that high of a standard of living. Okay, so then we would take a country like Switzerland, maybe. Switzerland has a fairly low energy consumption, but yet they have an efficient or a GDP similar to that of the United States. I mean, not a little lower, obviously, but right, Switzerland would be a much more efficient country. right? They're not in terms of energy, right? They're having more or less the same standard of living in the United States, but they're using significantly almost half the amount of energy to do that, right? Versus you might take Russia, which could be various reasons that Russia is this way, but which uses obviously less energy than the United States, but also makes significantly less or has a significantly lower GDP than the United States. So they would be a much less efficient country because, right, they're using quite a bit of energy considering they're not really having that higher standard of living or GDP. Maybe because it's cold there all the time. Who knows? If you take a look at the graph on the right, this would show our energy intensity. So basically, what we were just talking about, right? The amount of energy they use to get amount of some GDP. So how efficient are they with their energy usage? Um, and we can see what happened to the United States one over time, right? So in the 1920s and 40s, we're seeing that right, we were very intense in our energy usage. Now, if you think about it, right, this was we had the Industrial Revolution happening, and we were just not very efficient with that, right? Um, just think about like how we were doing things. We had big, huge factories that were not efficient at all, versus kind of a more modern factory, which is going to be much more efficient. So we're seeing that we our energy efficiency or energy intensity is decreasing, meaning that we are able to we're probably using way more energy now than we were back in the 1920s and 30s and 40s. However, we are able to do a lot more with that energy that we're using. So, like, um, this is just showing that we are more efficient with our energy because than we used to be. So that's just because we're more efficient about things now, right? The way that we do things now is more efficient. So that's what that's kind of showing you is that the energy intensity, the amount of energy that we have to use in order to gain $1 of GDP has decreased over the years because we have more efficient ways of manufacturing things and making. So big picture for all of this, right? So as long as the world is primarily powered by fossil fuels, we need to decrease the overall energy consumption because it's bad for the environment, right? Producing or it's contributing to global warming, and that is a huge problem. And so we need to be conscious of that. So like we need to figure out a way to decrease the energy consumption of the world as long as we're being powered by fossil fuels. Decreasing the energy intensity is one way to do that without impacting the standard of living, right? If we can continue to have a similar level of GDP, then without necessarily with using less energy, then obviously that's going to cause our energy intensity to decrease, meaning that we're basically getting at the same standard of living without having to use quite as much energy, being more efficient with our energy. Right? Therefore, we're using less energy, using less fossil fuels. Right? The other way to look at this is that if we can figure out ways of creating power or energy with cleaner fuels, right, then the overall consumption of energy is less of an issue, right? Because it's not contributing to global energy or to the climate change. So that's kind of all of this, looking at how we use energy, how much we use, the rate at which we use it, and the efficiency at which we use it, and then why we even care about that, right? Because we want us to be to use our energy efficiently. We want to be able to have the best possible life we can without um, with the least amount of energy that we can have use. Basically, is what this is all about. Okay, cool. Thank you very much. I hope you enjoyed this. Have a good day. Bye.